You tap a video and it appears inside your house. It feels as if the internet lives in the router, but the router is not the source. It is the last visible box in a chain that may cross a street cabinet, an ISP network, a data center, an exchange point, a DNS resolver, and sometimes an ocean before the first frame reaches your screen. The internet is not one cable and not one cloud. It is a network of networks. A request has to be broken into packets, addressed, routed, answered, and assembled again. If any part of that chain adds delay, the user usually sees only one symptom: the page stalls or the video buffers. So this episode follows one request from a home to the system behind it. We are not asking why Wi-Fi is annoying. We are asking what has to work before Wi-Fi has anything useful to deliver. The first hidden system is actually inside the home. Your device may not touch fiber directly. It talks by radio to a router or access point. Walls, distance, neighboring networks, and device quality all affect this tiny final hop. The global internet can be healthy, while the last 10 meters inside the house are the weakest part. Then the router hands traffic to the access connection. In many fiber homes, an optical network terminal converts light from the provider network into usable Ethernet for the router. The customer sees a plastic box. The system sees an interface between a private home network and a managed provider network. This is why slow internet is hard to diagnose from the couch. The failure can be local Wi-Fi, the router, the modem or terminal, the street connection, the provider core, a DNS issue, a congested route, or the service being contacted. One spinning icon hides many possible causes. Outside the house, the request enters what providers call the access network or last mile. This is the part that varies by address. One street may have fiber, another may use cable. A rural road may depend on fixed wireless or satellite. The internet is global, but access is local and very physical. At a cabinet pedestal or node, many individual homes become part of a shared provider design. Splitters, coax nodes, radios, or cabinets aggregate local demand. This is where the idea of your personal connection meets the economics of serving a neighborhood. Capacity is planned, shared, upgraded, and sometimes exhausted. The FCC broadband map exists because availability is not the same everywhere. A provider can serve one side of a road and not the other. A building can have one technology available, while another nearby has several. The internet reaches homes through construction decisions, not magic coverage. The access network feeds into a provider point of presence. Here, traffic is aggregated, authenticated, monitored, and pushed into larger routers. The home request now becomes part of a regional flow. It carries addresses that tell networks where it came from, where it should go, and which systems are allowed to handle it. From there, the request may move across a backbone. A backbone is not one road. It is a mesh of long-haul fiber, routers, and interconnection points. Packets can cross different paths depending on policy, capacity, and failure. The route that feels instant to you may be a negotiated path between networks. Sometimes traffic passes through an internet exchange point, a place where networks connect to exchange traffic more directly. Keeping traffic local can reduce distance, cost, and latency. The exchange is one of the reasons the internet is not a single company. It is a set of agreements made physical in racks and fiber panels. The shortest map distance is not always the chosen internet path. Business agreements, network policies, outages, and congestion all shape routing. A request to a nearby service can sometimes travel farther than expected, while a distant service may feel fast because it has a node close to your provider. Before many requests can leave with confidence, the system needs an address. DNS translates names people understand into addresses computers can use. ICANN describes DNS as a distributed directory, which matters because there is no single magic book under your router. The lookup itself is part of the journey. If the content is popular, the answer may not come from the original server far away. It may come from a content delivery network node closer to the user. This is one of the internet quiet tricks. The video feels global, but the copy you receive may be stored in a nearby data center. A data center is not an abstract cloud. It is a building full of power systems, cooling, servers, switches, and fiber. When the request reaches the right service, machines retrieve data, compute a response, and send packets back. The cloud becomes real the moment you follow the cable into the room. For international traffic, the path may include undersea cables. Telegeography maps the cable systems and landing points that connect continents. The cloud across the ocean is still a physical route. glass fiber in protected cable, repeaters, landing stations, and terrestrial networks on both sides. Speed is not one number. Latency is the time before something responds. Throughput is how much data can move. Packet loss is when pieces vanish and must be resent. A video can buffer because capacity is tight, because latency is high, because packets are lost, or because the server is slow. Congestion is the internet version of a traffic jam. Packets are still moving, but they wait in buffers, take longer routes, or get dropped when queues overflow. To the user, congestion looks emotional. The call freezes, the game spikes, the page half-loads. Underneath, the system is making queue decisions. A physical cut can also change the internet without destroying it. If a route is damaged, traffic may move around the break, but the detour can be longer or more crowded. Resilience often means service continues imperfectly. The outage you feel may be the cost of finding another path. That is why the same symptom can have different causes. A speed test may look fine while one app fails. A neighbor may be slow while you are not. A phone may struggle while a wired computer works. The visible symptom is simple because the screen is simple. The path behind it is not. Now run the path backward. The response leaves the service, crosses data center switches, provider links, exchange points or transit networks, the ISP core, the local access network, the cabinet, the drop, the router, and the air inside the house. Only then does the screen make the internet feel local. A home connection is therefore not one service. It is a chain of successful handoffs: radio to router, router to access link to provider, provider to the broader internet, name to address, address to server, server to response, response back through the chain. The next time a page opens instantly, the miracle is not that the router blinked. It is that a global packet logistics system stayed aligned long enough for the final hop to look effortless. The internet gets to your house by arriving everywhere else first.